to be somewhat more disciplined today than yesterday. But since that was such an interesting discussion, I didn't want to cut it off. And I held my tongue, because I also had lots to add, but I'm I have been informed that I've been mispronouncing my esteemed colleague, Dr. Baydash, improperly. So I beg forgiveness, and I'd like to welcome him to start his presentation. Mic is on, and you're welcome to start. So let's welcome him.
Thank you. Unlike Jay Winter, I do not break out in a rash if I read a paper. However, I thought my paper was on the long side, so this morning I tried excising a few paragraphs here and there. So if you're trying to follow the text, you may have to jump around a bit, for which I apologize. But anyway, I'll proceed with nuclear winter and the end of the age of agriculture. And in this paper, I want to elucidate the development and ultimate use of nuclear weapons, and then the ensuing arms race. And this is the finality of what Jeff Rubinoff has termed the end of the age of agriculture. Into this period of uncertainty, the end of the age of agriculture, the nuclear winter phenomenon was revealed to the public in 1983. It suggests that cities will burn in a nuclear war. They'll inevitably be targeted, propelling black smoke high into the atmosphere, and the blocked sunlight will fail to warm the Earth's surface. And because of this, this climate change, meaning lowered light and lowered temperature, and in addition, reduced rainfall, agriculture will falter globally. So it is all the more important that new political and social institutions be developed quickly to avoid such a calamity. What were the steps that led to the end of the age of agriculture? What did significant participants think that they were doing? Some answers emerge if we focus upon the beliefs of scientists, mostly nuclear physicists, about the release of atomic energy. At first, they denied the likelihood that it could happen. Then, they expected to control when and if atomic energy would be used. Finally, in frustration, they demanded to be heard concerning their fear that the bomb had become an intolerable weapon. These views were influenced by their initial belief that scientists had rather little impact on society, to their eventual recognition that they had made possible the end of civilization. Can the atom's energy be harnessed? This is pre-discovery of nuclear fission. Pandora, of Greek mythological fame, incautiously opened a box and allowed to escape the ravages of human mind and body. Only hope remained to comfort mortals. The discovery of nuclear fission at the end of 1938 presented some scientists with a modern counterpart to Pandora's box. Would the splitting of uranium lead to inexpensive energy that might revolutionize the world's economy? Or would the product be instead a bomb of awesomely destructive power? Long before the discovery of nuclear fission, scientists knew that the atom contained a lot of energy. After Henri Becquerel, whom you see on your screen, discovered radioactivity in 1896, Marie and Pierre Curie and Gustave Beaumont, their colleague, he was a chemist, they were physicists, discovered the radioactive element radium in 1898. At that time, scientists recognized the outpouring of energy from this material because radium glowed in the dark. They knew that there had to be an energy source somewhere in there. An American chemist suggested that bicycle lamps would now have lanterns powered by radium. As early as 1902, Frederick Soddy, who worked at McGill University in Montreal with the physicist Ernest Rutherford, wondered if the enormous amount of energy in the atom derived from the sun. The sun was the only source they could think of. Nothing on Earth was possible to produce so much energy. Is this not?
Somehow there's buzzing. There's buzzing.
Okay, that's buzzing. I'll buzz. This one I think sounds a bit more muddy, but let's hope. Yeah, we'll see. Soddy wrote that the Earth was a storehouse stuffed with explosives, inconceivably more powerful than any we know of, and possibly only awaiting a suitable detonator to cause the Earth to revert to chaos. Also in 1903, Pierre Curie and Albert Laborde, a man working in his laboratory, recognized that radium kept itself warmer than its surroundings. They measured a few degrees difference between a radium solution and a comparable solution without the radium. Now, editorial writers converted this microscopic laboratory measurement of heat into macroscopic amounts that the layman could understand in the newspapers and journals, and noted that the energy in 1 gram of radium could elevate 500 tons a mile high. They were talking about battleships being elevated a mile high, while an ounce of radium could propel a 50 horsepower automobile at 35 miles an hour around the Earth. You see what the technological terms were in those days: battleships and automobiles. Rutherford, the central figure in radioactivity and early nuclear physics, dropped his caution on one occasion and speculated that, could a proper detonator be discovered, an explosive wave of atomic disintegration might be started through all matter. He thus became associated with the idea that some fool in a laboratory might blow up the universe unawares. The energy in radioactivity showed itself in the expulsion of rays and particles. The much-studied gamma rays and the alpha and beta particles, also much studied. This energy was many times greater than that released in almost all chemical reactions. But as something of a damper, it was recognized that while one atom can influence another in a chemical reaction, this is not the case in an atomic transformation. There, each atom has a statistical probability of rupturing in the average period called a half-life, but the half-life cannot be altered. By the 1920s, Rutherford's recognition that the atom has a nucleus, plus Albert Einstein's E equals mc squared relationship equating mass and energy, and the increasingly accurate atomic weight measurements by F.W. Aston in the Cavendish Laboratory 2 in Cambridge. He invented the mass spectrometer and was able to measure atomic masses. All these allowed calculations to be made of the energy released in specific nuclear transformations. This stimulated still more speculation and provided the basis for calls for a research moratorium. Scientists were depicted as socially irresponsible. They cared more for knowledge than for humanity. Robert Millikan, a physicist at Caltech, and the man noted for building Caltech into its current eminence, rejected the idea of a research moratorium. He reasoned that the heavy elements, among which the radioactive elements had been found, comprised less than 1% of all matter, and he thought that was too trivial a fraction to worry about. Of course, he was incorrect. The richness of an ore doesn't really matter if somebody is willing to pay to mine it. So it's a matter of economics and desirability, not so much a matter of rarity. So a scientist can be incorrect.
Millikan was a very devout person, and he argued that the Creator has put some foolproof elements into his handiwork, and that man is powerless to do any titanic physical damage. Again, Millikan was wrong. But by way of note, by the way, rather, note that scientists do make statements that sound like scientific conclusions, but they really are more matters of opinion. Despite the naysayers, speculation about harnessing atomic energy was rekindled with each scientific advance. This occurred, for example, when John Cockcroft and E.T.S. Walton built a particle accelerator in Rutherford's Cavendish Laboratory at Cambridge University. And with it, in 1932, were able to disintegrate the element lithium. This device and other atom-smashing machines, such as the cyclotron invented by Ernest Lawrence at the University of California campus in Berkeley, made control of the atom seem much closer. And such is the context for Rutherford's headline-making comment at the 1933 meeting of the British Association for the Advancement of Science, where he said that anyone who says that with the means at present at our disposal and with our present knowledge, we can utilize atomic energy is talking moonshine. Moonshine obviously was the term for something that we would have a different term for. Rutherford was irritated by speculation that he wanted to shut down. A year later, Albert Einstein was equally critical of success, calling the effort fruitless. In the right-hand column, it says, atomic energy hope is spiked by Einstein. And the Pittsburgh Post-Gazette has the series of photos of Einstein on the front page. And if something gets above the fold on page 1, it's considered news. For 4 decades, this argument went back and forth. And it was not a minor issue, as it attracted the attention of a host of distinguished scientists, including more than a dozen who already were or who would become Nobel laureates. So whether the atom had energy, whether this energy could be extracted, was one of the hot topics in physics. But this public discussion was not, with hindsight, especially innovative or profound. Some of the latest discoveries were incorporated into the arguments, such as the view that the neutron, discovered in 1932 by James Chadwick, again in Rutherford's Cavendish Laboratory, which obviously was a hotbed of this new physics, and the suggestion that the neutron might be the magic bullet needed to split the atom. Other ideas were curiously absent, such as the need for a chain reaction. And yet that's largely a chemical process, and the people we're talking about were mostly physicists. Only the refugee physicist Leo Szilard pondered the question about a chain reaction, and he placed this in a secret patent that he assigned to the British Admiralty. He wanted to keep the idea from circulating to Nazi Germany. Scientists and the public lacked a high degree of fanciful thinking, while at the same time they exhibited an almost blind confidence in the future conquest of nature. This is not meant as criticism of the scientists or the public. Rather, it's an effort to emphasize that scientists, even the most creative ones, usually behave as ordinary human beings, and the human condition, thanks to Pandora, is basically one of hope with few glimpses of distant peaks or even the path toward them. Now, let me talk about the reaction by scientists to the discovery of nuclear fission. After uranium fission was discovered at the end of 1938, Rutherford was criticized for having poured cold water on the release of atomic energy. The criticism, I feel, was misguided, for Rutherford clearly said that he was discussing the knowledge and the means at their disposal in 1933. He could not have known that a new phenomenon of nature, nuclear fission, would be revealed more than a year after his death. This discovery was made by chemists Otto Hahn, that's Rutherford, chemists Otto Hahn and Fritz Strassmann, working in Berlin. and interpreted by physicists Lisa Meitner and her nephew Otto Frisch, who had both fled Hitler's Germany. Neutrons striking uranium nuclei caused them to split into two roughly equal fragments, in the process converting a substantial amount of mass into energy. This news traveled across borders rapidly, even before scientific papers were published in the open literature. Physical confirmation of the energy release after the chemical discovery came quickly. Physicists around the world recognized that an uncontrolled release of energy could yield an explosive of awesome strength, while a controlled release might mean an energy source of great benefit, a nuclear reactor. Many deplored the possibility of creating such a weapon, but the concept of social responsibility among scientists, although fairly well discussed by the 1930s, was actually not very strong in practice. They didn't have much opportunity to practice what they were talking about. Few scientists would, for moral or ethical reasons, decline to pursue fission research. These ideas were discussed in scientific papers and in newspapers. The concept was not secret that nuclear fission occurred. What was secret was that projects to achieve bombs and reactors were begun in the United States and the Soviet Union and in Germany and Japan. The United States, joined by Britain and Canada, succeeded first in constructing the nuclear reactors, which at Hanford, Washington, produced the new element plutonium. And at Oak Ridge, Tennessee, the big machines they built produced or separated the fissionable isotope U-235, uranium-235, from the far more common U-238. Then these concentrated materials, plutonium and U-235, were sent to the weapons laboratory at Los Alamos, where people working under the directorship of J. Robert Oppenheimer fashioned these materials into the bombs that were dropped on Hiroshima and Nagasaki in August 1945. As suggested above, in the early years of the Manhattan Project, scientists rarely questioned the morality of creating a new weapon. Virtually none declined to investigate if nuclear fission could be turned into a bomb. Indeed, they rather doubted that it could, or that they would be the ones to do it. If any moral issues were involved, they thought it would be their students' generation that would have to deal with these moral issues. So for them, staying ahead of the possibility that Germany might succeed first was paramount. When the project then appeared likely to succeed, the pressure of work again banished moral questions from their minds. Only when research and development activity slackened at the sites other than Los Alamos, where the bombs were being fashioned, did some scientists focus on the larger picture. And only physicist Joseph Rotblat, sorry, that's Oppenheimer, only the physicist Joseph Rotblat, originally from Poland, left Los Alamos before this completion because he had come there with the specific idea of preventing Hitler from getting the bomb first. And it was obvious that the war in Germany would be over before the bombs would be ready, and therefore he wanted no part of its use anywhere else. The metallurgical laboratory at the University of Chicago, where a lot of the research was done, was home to several European physicists whose protests became famous. In efforts to avoid bombing civilians, or at least to give the Japanese government an opportunity to witness a test explosion and then surrender, Leo Szilard had an audience with Secretary of State designate James Burns. He contacted Supreme Court Justice Felix Frankfurter, and he circulated a petition among the scientists. In the same laboratory, Nobel laureate James Franck chaired a committee that produced a famous report to the Secretary of War, again seeking alternatives to bombing civilians. In the lone moral protest at Los Alamos, physicist Robert R. Wilson got Oppenheimer's permission to hold an open discussion for the scientists. They obviously did not succeed, and let me talk now about the reaction of the scientists to the acquisition and use of nuclear weapons. President Truman announced the destruction of Hiroshima soon after it occurred. Newspapers and journals of opinion had a feeding frenzy in the months afterward, a discussion to which many scientists contributed. While the great majority of the scientists believed that construction of the atomic bomb was necessary, virtually all were appalled by its ability to demolish a city. Although he never expressed remorse for his central role in directing the Los Alamos laboratory, Oppenheimer captured the widespread feeling in a speech in 1945 when he said, "We have made a thing, a most terrible weapon, that has altered abruptly and profoundly the nature of the world. We have made a thing that by all the standards of the world we grew up in is an evil thing." So the word evil is associated with nuclear weapons early. While governments and the military in several countries felt obliged to construct nuclear weapons, scientists were among the leaders in trying to stuff the nuclear genie back in its bottle. Many who had worked on the bomb project felt that their views on policy issues were not irrelevant. And this was controversial because other people asked, what moral, ethical, political smarts do scientists have? They know how to do technical things. Why should we listen to them when they talk about ethical and moral issues? The scientists, by contrast, said, we're among the few people thinking about these things, and we have some knowledge about the bomb and its consequences, and we should be heard. So it was not a simple issue even in 1945. Initially, the public seems to have welcomed the informed voice of scientists in the political area, increasingly impressed by a profession whose pursuit is the truth. Challenging military control of the atom in 1945-1946, scientists, quote, alone have faced the puzzle of the bomb socially and realistically, according to an editorial in the New York Times. And yet on the same editorial page, another writer noted that not even the fact that a scientist has had a share in making the atomic bomb qualifies him to map national policy or read the future. Nonetheless, American scientists were successful in helping to fashion the Atomic Energy Act of 1946, strong testimony to their political acumen, which they developed rather quickly. They were far less successful in moving the great powers to place all control of nuclear weapons in the hands of the newly formed United Nations. That went nowhere. Scientists in general, at least those who were vocal, were unhappy with the use of the atomic bomb, but not so the public. Months after the end of the war, American citizens remained bitter and bloodthirsty against the Japanese. Not so much against the Germans, curiously, but against the Japanese. There's a lot of racism involved in that. A survey in Fortune, a magazine of the business community, showed that 53.5% of those questioned were satisfied with the use of the bomb over 2 Japanese cities, while an additional 22.7% wished that even more atomic bombs had been dropped had they been available. They wished that more had been completed and able to be used. Thus, more than 3/4 of Americans surveyed approved using nuclear weapons against Japanese cities. Several prominent scientists, by contrast, joined publicly to express their rejection of the bomb in future conflicts. One World or None, a popular book that sold more than 1 million copies, was a collection of essays by Albert Einstein, Niels Bohr, Arthur Compton, Robert Oppenheimer, Leo Szilard, and quite a number of other very distinguished scientists. Their major theme was that not only was international control of the bomb necessary to prevent an arms race, but that nuclear weapons were too horrible to be used again. The always eloquent Robert Oppenheimer, in a speech at MIT in 1947, encapsulated for many scientists their torment when he remarked, that physicists have known sin. And that was not a popular comment among many others, other scientists who felt that they were entirely justified in doing what they did. In the post-World War II period, Manhattan Project scientists organized into the Federation of Atomic Scientists, which soon enlarged its membership by evolving into the Federation of American Scientists. The FAS is still alive, having over the decades embraced environmentalism and social concerns in addition to nuclear issues. For all these years, it has been a highly respected voice of moderation, focused on Capitol Hill, the media, and the scientific community. For a brief period, the Emergency Committee of Atomic Scientists acted as a fundraiser for these kinds of efforts. With Albert Einstein, its very, very visible chair, letters soliciting donations were hard to reject. During this half-century and more, the Bulletin of the Atomic Scientists has also flourished, matching the FAS in raising its eyes from nuclear matters to comment also upon environmental and social problems. The Bulletin has a worldwide readership which watches closely the clock on its cover for the number of minutes to Armageddon at midnight, and periodically they move the clock forward and back depending on how hot world problems are. In addition to these persistent examples of scientists embracing the cause of nuclear disarmament, or at least arms control, a few other specific cases stand out. In the autumn of 1949, faced with evidence that the Soviet Union had just tested its first atomic bomb, which we, of course, had to give a nickname, so we called it Joe 1 after Joseph Stalin, the United States pondered what its reaction should be. Foremost among the suggestions was pursuit of the so-called super bomb, labeled a hydrogen bomb because it worked by fusing light atoms of hydrogen together, compared with the atomic bomb, which is a fission bomb splitting heavy atoms of either plutonium or uranium-235. Whereas atomic bombs have a practical limit of explosive power of about 1 megaton before the pieces blow themselves far enough apart that the chain reaction stops, there is no theoretical limit to the power of a hydrogen bomb, other than the limit of the weight of the aircraft to carry the bomb or the missile to carry the warhead. Estimates that the explosive power of practical H-bombs were about 1,000 times that of atomic bombs were common. The U.S. Atomic Energy Commission, the AEC, had a distinguished board of scientific advisors called the General Advisory Committee, the GAC. Leading it was the ubiquitous J. Robert Oppenheimer, who seemed to chair or write the reports for a number of government committees. The GAC report in October 1949 was unanimous in urging the commissioners, the Atomic Energy Commission, not to develop hydrogen bombs. Such weapons were tools for, they said, exterminating civilian populations. In other words, these scientists argued that a super bomb might become a weapon of genocide. In an annex, physicists Enrico Fermi and I.I. Rabi introduced questions of morality. They wrote that it is clear that the use of such a weapon cannot be justified on any ethical ground which gives a human being a certain individuality and dignity, even if he happens to be a resident of an enemy country. It is evident to us that this would be the view of peoples in other countries. Its use would put the United States in a bad moral position relative to the peoples of the world. While scientific advisors were not expected to advance ethical arguments, Fermi and Rabi nevertheless felt obliged to emphasize that it is necessarily an evil thing considered in any light. President Truman obviously listened to other advice, and research accelerated on fusion weapons, with successful testing of a device in the early 1950s. But this event serves as an example of the profound moral turbulence in which scientists found themselves. And there are some other examples that I will skip at the moment. And the second half of the 1950s also saw an international campaign to collect the signatures of scientists on a petition opposing the atmospheric testing of nuclear weapons. Both superpowers by this time had developed the hydrogen bomb and were trying to perfect its designs. Hundreds of tests were conducted, the vast majority being explosions atop towers or bombs dropped from aircraft. The United Kingdom successfully tested its atomic bomb in 1952 and its hydrogen bomb in 1957. France acquired the atomic bomb in 1960. These added a few more atmospheric explosions to the total. Bomb debris contains the residue of the unfissioned uranium and plutonium and the weapon's casing, but most importantly, consists of the fragments produced when uranium and plutonium fission or splits. These heavy elements break apart, as I said before, into two almost equal pieces plus the neutrons needed to keep the chain reaction going, meaning that the fragments are elements that lie in the middle of the periodic table of elements. Usually they are radioactive. Winds blow this radioactive debris to great distances, particularly if the mushroom cloud rises into the stratosphere, and then the jet stream carries the radioactivity around the globe. Such fallout was detected in many places, in drinking water, on pasture land where it made its way into milk that children drank, and notably dusted the Japanese fishing boat, the Lucky Dragon, and contaminated its tuna catch. The boat happened to be downwind of an American H-bomb test at Bikini Atoll in March 1954. Countries around the world now became very concerned about global fallout. American chemist Linus Pauling who had not worked on nuclear weapons, led the efforts among scientists to force members of the nuclear club, the nations that had the bomb, to move their testing underground, or better still, to stop altogether. In 1957, he collected some 2,000 signatures and sent the petition to President Eisenhower and to the United Nations. This was headline material, and politicians who favored testing, of course, to keep the American arsenal strong, endeavored to paint Pauling as a communist, a charge he denied under oath. Nonetheless, he was denied his passport, denounced by the chairman of the House Committee on Un-American Activities, and subpoenaed before a Senate investigatory committee. Pauling expanded his position to include scientists worldwide, and by early 1958 sent some 9,000 names to the United Nations. The US and the USSR then agreed to a testing moratorium in 1958. It was a gentleman's agreement. If you don't test, I won't test for a year. And eventually, they signed the Limited Test Ban Treaty in 1963. This permitted testing only underground, prohibited testing in the atmosphere, underwater, and in space. If you're cynical, you can say that the US and the USSR agreed to this NPT because they had, by that time, developed the capability of testing underground. They could do it, and they could get as much information as they needed from these underground tests, so they could look good to the public and say we're based on environmental concerns, not testing in the atmosphere. For these efforts, the Nobel Peace Prize was awarded to Pauling in 1963. He had previously won the Nobel Prize in Chemistry. He's the only person to win Nobel Prizes in peace and in science. Marie Curie has 2 Nobel Prizes, one in physics, one in chemistry, and John Bardeen, an American physicist, had 2 Nobel Prizes in physics. But getting 2 is rare. Linus Pauling and Otto Hahn, who made a protest in Germany earlier that I omitted, may have been outsiders. Those whose advice governments could choose comfortably to ignore. But insiders also protested nuclear weapons and the conduct of the arms race. Physicists Hans Bethe and Richard Garwin were consummate insiders, having contributed to the successful development of the American arsenal and having served on important advisory committees. Their public protest in 1968 against development of the anti-ballistic missile, the ABM, therefore was stunning, for it indicated that protest from within the administration was fruitless. Scientific American, a leading magazine which interpreted scientific advances for the layman, also presented articles on the interaction of science with society. The growing ABM controversy was ideal for its pages. Bethe and Garwin argued that the ABM could easily and inexpensively be overwhelmed simply by increasing the number of attacking missiles. This had recently become easier to accomplish, as missiles could carry more than one warhead, a capability known as MIRVing, MIRV standing for Multiple Independently Targetable Reentry Vehicles. So you had what they called a space bus. You could have up to, as it turned out, 14 or so warheads atop a single missile. And eventually they developed the technique to be able to send these to different targets along the flight path. So they all didn't land on one target. So it was easy now to overcome a ballistic missile defense. In addition, if you built this sort of thing, this would ratchet up the arms race considerably. While newly elected President Richard Nixon endorsed the construction of the anti-ballistic missile system, he made the defensive weapon a significant part of his style of bargaining from strength, as he called it. In other words, having weapon systems to trade away. So his administration in 1972 signed with the Soviet Union the ABM Treaty, which limited construction to such an extent as to make the system nearly worthless. Another insider was Andrei Sakharov, the brilliant theoretical physicist credited with a major role in the development of the Soviet Union's hydrogen bomb. Initially willing to work on weapons because he felt that he was helping his country resist domination by the United States, he lived for 2 decades within the closed world of the weapons laboratory. But his moral conscience developed, and he became increasingly concerned with the danger of mass destruction should such weapons be used. In 1962, Sakharov personally telephoned Premier Nikita Khrushchev to warn, unsuccessfully, that a scheduled test, this was an atmospheric test, would endanger many people with its radioactive fallout. Nonetheless, his influence helped to move the Soviet Union toward the Limited Test Ban Treaty of 1963. Now increasingly outspoken, Sakharov's critical writings were circulated in samizdat because they couldn't be published legally, and found their way to publication in the West. In 1968, he lost his security clearance and was regarded as one of his country's leading political dissidents. For his courageous activities, he was awarded the Nobel Peace Prize in 1975. My goal so far has been to illustrate that among those scientists who made public comments about nuclear weapons, most have opposed their stockpiling, testing, and use. From their belief before World War I that they had little influence on society, their position evolved to where they felt that the policy changes they recommended were mandatory. Now let me turn to nuclear winter, and Robert, I have to know how to get to the other PowerPoint. Excellent, thank you. Nuclear winter provides another illustration for the theme of this conference that war is no longer a means for conquering land and people. In addition to the terrible physical destruction caused by the blast and heat of a nuclear explosion, and the medical problems caused by radiation from the detonation, and by radioactive fallout, nuclear weapons also have the potential to alter the climate. This could lead to the destruction of civilization. Curiously, the nuclear winter phenomenon was discovered not by scientists at the nuclear weapons laboratories in America, meaning the Los Alamos and Livermore weapons laboratories, but by scientists of the National Aeronautics and Space Agency, NASA, another scientist at a private defense contractor, and a fifth scientist at a university. These 5 people had a broad range of interests and brought to bear on the problem information from fields of quite diverse interests. Nuclear weapons effects, of course, particle microphysics, atmospheric chemistry, fire and smoke research, volcanic eruptions, ozone depletion, planetary studies, and dinosaur extinction. Normally, scientists don't have such a broad range of interests, but these 5 gathered together enough information and became expert enough to draw together the necessary information. Their computer simulations of various possible war scenarios in which cities would inevitably be targeted and burned suggested that much black smoke and soot would be lofted. It would remain high in the atmosphere, above most of the clouds that normally wash rain out, above the clouds whose rain normally washes particulates out of the air. And then as sunlight was absorbed by this high layer, the Earth's surface would cool markedly. Temperatures might drop tens of degrees Celsius below normal, allowing fresh water in many locales to freeze, and this climatic change could last for months. Let me show some pictures that were put together mostly by Carl Sagan. He commissioned most of these images. Sagan, as you probably know, was a very well-known astronomer, atmospheric physicist, and also a media darling. He was very articulate, photogenic. His Cosmos TV series was perhaps the most watched science series on television. And if anyone could get a message across to the media, Sagan could do it. And he liked illustrative material. So here is a picture of the Earth before nuclear war. Here's a picture of a ground burst. From an angle, the fireball reaches into the stratosphere. You have the troposphere that rises between, say, 7 and 15 miles above the surface, depending on whether you're near the equator or the pole, and the stratosphere, which rises many miles above that, and then that thins out into space. Here is a painting of a number of nuclear explosions rising above the clouds. Now you see the smoke plumes from the fires that have been started. And while you have oil fields and forest fires, city fires are the greatest source of concentrated flammables, and that's why they focused on cities in their studies. And here, looking from above the North Pole where you see the ice cap, you see the explosions around the northern hemisphere. The black clouds are starting to spread on the illuminated side of the Earth. And now you have not too many clear patches. The northern hemisphere is pretty well covered by black smoke. A different picture of the same thing with the smoke drifting southward. Normally, the northern and southern hemispheres have different or separate circulation patterns of air. This kind of climatic assault would obliterate that boundary at the equator, allowing smoke to go down into the southern hemisphere. And here the southern hemisphere is rather well covered in darkness, even more so. This is the one graph I'll show merely to give you an indication. The x-axis is time in days, and the vertical axes are Celsius on the left, Fahrenheit on the right. And if you look at the dotted line near the top, that's ambient temperature. That's the average temperature of the Earth. So that's where they start. And if you look at that case 14, 100 megatons, this was the smallest war scenario that they looked at. The superpowers have in their arsenals at that time, and this is the early 80s, something of the order of 10,000 megatons of explosive force in their nuclear weapons. So 100 megatons is about as small a war as you're going to get. Many people thought this was too small a war to be credible even. But if you distribute these in 1,000 warheads on 100 or so cities, making sure that these cities burned and burned well, what will happen is that within 20 days or so, 20, 30 days, temperatures will drop below 0 Fahrenheit, and it will take more than 100 days to come back for case 14 up to the ambient temperature. So this is a fairly long-lasting effect. Larger conflicts in these other scenarios will take longer to get back up to ambient. But they focused upon this case 14 of 100 megatons because they themselves were so struck by disbelief that such a small, relatively small war could cause so much damage. And these are some other paintings Sagan commissioned, just to give people an idea of what conditions might look like in urban situations, on the farm where there's not much left of agriculture. It isn't just radioactivity. You have toxic chemicals, oil and gas burning. It's a stew of terrible materials. Central America would be affected, just to show that it isn't just North America that's at risk, or Europe. And some pre-war scenes. This is of the North Woods. And after the war, everything is killed. And then, at some later time, a lightning strike, for example, could ignite the dry, standing wood. So you have further assault on the atmosphere and whatever's left. And the saltwater environment pre-war, and turbulence and dead everything thereafter. Here's a picture of 3 of the individuals of this team of 5, Richard Turco, Carl Sagan, and Brian Toon. A picture of James Pollock. He was at NASA. And I don't have one of Tom Ackerman. Paul Ehrlich led the biological studies initially, and he's the famous population growth person at Stanford, so he already was well known as well. And that's a plug for my book. And let me hold that for a moment. In the few years after this first announcement of nuclear winter near the end of 1983, the computer models that were used were improved greatly. They went from one-dimensional models to three-dimensional models. They stopped taking averages and were able to put in some specific details such as day-night temperatures and seasonal changes. And in general, more accurate data were entered into the programs and many assumptions were tested. And the overall result was that the temperatures would not drop quite as far as I showed you in that graph. and the lower temperatures would not last quite as long. Nonetheless, the climatic insult remained severe. In the United States, the National Academy of Sciences conducted a major review of the field and found that it could not deny that the nuclear winter effect might occur. There are so many what-ifs. There are so many choices that one makes in selecting what a scenario is going to be that there really is an infinite number of possibilities. So some lead more likely, some lead less likely to the occurrence of a nuclear winter. But the National Academy of Sciences was saying that we can't say it will occur because the circumstances might not lead to it, but we can't say that it cannot occur, and that was the important thing. Internationally, an even larger review was executed, and this was done by the Scientific Committee on Problems of the Environment, called SCOPE, an agency of the International Council of Scientific Unions, called ICSU. And this report, released in the latter part of 1985, reconfirmed the possibility that the nuclear winter effect might occur. But the report moved in a strikingly new direction, for it studied the biological effects of nuclear winter conditions. The investigation of biological effects had been adamantly opposed by the administration of President Ronald Reagan, which really wanted nuclear winter to go away, for it interfered with the Reagan desire for arms modernization. Some 300 scientists from around the world contributed to the SCOPE report, and it was on both physical and biological sciences. They enumerated the many physical stresses on the environment, such as acute and chronic climate change, global and local fallout, ultraviolet light, toxic aerosols, and so on. Then they looked at the effects of such stresses on the natural ecosystems and on agriculture, with emphasis on the latter because of its greater sensitivity and its importance for humans. SCOPE's goal was to evaluate the vulnerability of humans to disruptions in the availability of food. There were some 200 biological scientists, and they looked at the natural ecosystems, and they said they're totally inadequate to feed the Earth's population. They never were meant to do so. Without the benefits of agriculture, less than 1% of humanity could be supported. These scientists studied the vulnerability of crops to temperature variations, agricultural production and consumption records, import and export systems, and dietary patterns. For example, rice consists of more than 80% of the diet of nearly 2 billion people. The scientists concluded that darkness and cooler temperatures were but preludes to the collapse of agriculture in the Northern Hemisphere. Assuming a springtime or summer war, the next growing season would be lost. For a war that occurred in the autumn or winter, the agricultural losses would be less, but still significant. Many growing plants would be killed by a freeze, which is a major thing, a freeze. But a temperature drop of only 3 to 4 degrees Celsius, far less than the 35 degrees Celsius predicted in the first nuclear winter study, this would shorten the growing season and curtail the cultivation of wheat in Canada, in the northern part of the US, and in the Soviet Union. These are bread baskets of the world. Yields of rice, corn, and soybeans would suffer similar reductions, with a comparably small reduction in temperature at a critical time. Lowered temperatures would not be the only problem facing agriculture. Drought could affect India, Southeast Asia, China, Japan, and the African Sahel, as the monsoon rain patterns were disrupted. Non-combatant India alone might suffer more fatalities from starvation than would the US and USSR from the direct effects of explosions. Rice production could end in the Northern Hemisphere and possibly also in the Southern Hemisphere. Uncontrolled fires, increased ultraviolet light, toxic gases, and radioactivity would also imperil agriculture wherever it continued. Humanity would not perish, but with 1 to 4 billion people thrust into starvation out of an estimate then of 4.6 billion people on Earth, it would experience the most staggering blow in its history. Forget Hiroshima and Nagasaki the Biology Team Co-Leader Council. More accurate images of nuclear war were those of famine-stricken Sudan and Ethiopia. Even if climatic conditions return to normal in a year, the lack of seed stocks, farm animals, pollinators, fertilizer, pesticides, tractor fuel, irrigation equipment, and other farming needs could easily condemn agriculture to a slower revival on the course of the order of several years. What would happen, they asked, to a country with a good 6-month supply of food? Would half the population be given rations for a year until the next harvest? Or would the entire nation eat for half a year and then starve? The latter is more likely, as history shows famine often associated with siege. Some veterans of the nuclear winter studies a quarter century ago have recently revisited the problem. Using more powerful computers and improved climate models, they have the ability now to examine far longer time periods, look beyond the stratosphere above Earth, and include the effect of the oceans. They conclude that the calculations from the 1980s were correct. A nuclear winter condition would likely occur. Their new insights are that the climatic change would last at least a decade, much longer than previously estimated, and that a regional war, such as one between India and Pakistan, could ignite a global disaster. This would not require the much larger arsenals of the United States and Russia. It's felt that Pakistan and India have somewhere in the range of 50 to 200 atomic bombs. Hiroshima-sized bombs are slightly larger. These are considered small by today's standards. So nuclear winter has shown that a substance as tenuous as smoke could wreak havoc on a far greater fraction of Earth's living creatures than previously believed. Let me conclude as follows. As I've tried to illustrate, scientists found, I forgot to show you some slides, some pictures. These scientists who more recently revisited nuclear winter have published several articles in the last few years, the most recent being a popular article in Scientific American in January 2010. And they were looking particularly at the consequences of a potential war between Pakistan and India. And I have 3 pictures from their paper that show the stages of the war. You see the black cloud over the region of Pakistan and India on day 5. So after the bombs, the missiles, and so forth have flown back and forth, cities have burned, and a lot of smoke and soot has risen in that relatively localized area, day 5. By day 9, the winds have carried this black smoke and soot around the globe, and it's still fairly thick in that locale. And here's day 49. It's more tenuous, it's thinner, but it's spread across the globe. And what they're saying is that a war in the Northern Hemisphere, even what's considered a tiny war, not between superpowers, but between small nuclear states, can produce worldwide damage that is really just as bad as was predicted in 1983 for a major war between the superpowers. So it doesn't take that much. Oh, back to my conclusion. As I've tried to illustrate, scientists found and accepted their moral role in society after World War II. This does not, however, mean that their influence is great. With few exceptions, scientists have been on tap, not on top. They've been available to do the bidding of the politicians, but rarely have held political power themselves. I count just 2 secretaries of defense and 3 congressmen who were scientists. In the former Soviet Union, and I think still in Russia, they do elect to their parliament a great many more scientists. In America, scientists either don't want to run because they don't want to leave their profession, or the public doesn't think much of eggheads. and there just haven't been many scientists in Congress. We would do well to listen to their counsel, that of scientists, but I think that we cannot rely only on scientists to lead us into a better age. As Rubinoff has argued, the rewards of large-scale war are no longer agricultural, land and population, or even mineral resources. I wonder whether the old system still functions, still flourishes in some less developed countries. I might add that the rewards are not even the contemporary visions of economic, political, or psychic wealth. These too are susceptible to the ravages of nuclear weapons and strategic bombing. Note, however, that preparing for war is more lucrative and less dangerous than fighting a war. Defense industries consume a large slice of the U.S. federal budget. I think that a nuclear attack will occur only by accident, by miscalculation, or by gross stupidity. Deterrence is the rationale most cited for having nuclear weapons, and most military officers, I'm told, believe that if they are used, we have lost the game. So my respect for the military has risen as I've studied this issue more intensively. They know what the politicians seem to be denying. Who benefits from our current situation? Who are the warriors today? Our political leaders posture a lot but never lead troops into battle or place themselves in harm's way by other means. In the armed services, there are no sword-wielding horsemen leading a charge or sailors crying out, "Damn the torpedoes, full speed ahead." Military and civilian leaders are often middle-aged desk pounders, sometimes with PhDs, who manage conflict from afar via predator drones, robots, or they call them warbots now, and so forth. And these leaders contract out to private corporations many functions that were formerly performed by the military. All profit from the present system and are unlikely to encourage much change. To reach a new age in which we are safer, nuclear weapons must be abolished. Smaller nuclear nations are not likely to move in this direction without major reductions by the United States and Russia. We may be encouraged by recommendations for a world free of nuclear weapons by some prominent individuals who once advocated having a substantial arsenal. Former Secretaries of State, American Secretaries of State, of course, Henry Kissinger and George Shultz, former Secretary of Defense William Perry, and former Senator Sam Nunn have attained such enlightenment in recent years and have succeeded in attracting support from a number of other former officials. They also counsel that deterrence is no longer meaningful. U.S. President Barack Obama won the Nobel Peace Prize in 2009 for his articulation earlier that year in Prague of a world without the threat of nuclear Armageddon. Then the spring of 2010 brought a flurry of encouraging activity on nuclear issues. On April 6th, the Obama administration released its Nuclear Posture Review, which happened to be the first one, I believe, that was made public. They were usually classified and kept secret on previous reviews. This review explains U.S. policy on the use or threat of use of nuclear weapons. Notably, the circumstances under which such actions might occur are now more limited than they were before. On April 8th, Russia and the United States signed a new Strategic Arms Reduction Treaty, START. This further reduces the number of allowed nuclear warheads to 1,550 and the delivery vehicles to 700 with 100 more in reserve. The delivery vehicles are the aircraft, the ballistic submarines, and the ICBMs, the missiles, to carry the warheads. Certainly, it's a step in the right direction, but critics argue that it's a small step. Both superpowers have far more weapons in their arsenals than are considered necessary to be a minimal nuclear deterrent. The treaty has been submitted to the U.S. Senate, where treaties, unfortunately, often remain unratified. Some Republican senators expressed fear that the reduction specified would leave the U.S. with inadequate protection. They don't say inadequate protection from what, but waving the flag has always been politically effective. Building the momentum toward a nuclear-free world, 47 heads of state attended President Obama's call to a global nuclear security summit held on April 13th in Washington. The focus on this conference was to control both the weapons and the weapons materials. Finally, from May 3rd to May 27th, meaning it's still going on, the Nuclear Non-Proliferation Treaty Review is being held in New York. The NPT was signed in 1963, as I said before, and obliged the existing nuclear weapons states, which were the US, USSR, UK, France, and China, to work toward the elimination of these weapons. The non-nuclear signatories promised not to acquire such weapons and were assured to be free from such attack. And all states were to be free to pursue the peaceful uses of nuclear energy. In several reviews of the treaty over the years, the so-called have-not nations severely criticized the nuclear powers for their glacially slow progress toward ridding themselves of nuclear weapons. North Korea removed itself from the NPT shortly before it tested its first nuclear weapon. And both Iran and Syria are feared to be moving toward these explosives. They are signatories. So there is pressure for more intensive investigation by the United Nations International Atomic Energy Agency, the IAEA. Israel, India, and Pakistan, suspected or admitted nuclear states, have not signed the treaty. These recent events illustrate a strong worldwide desire to eliminate nuclear explosives and to increase the use of nuclear energy from reactors. Yet both are controversial. Some nations, for example France, claim their right to maintain their arsenals as a means of self-protection. And that's also certainly an argument heard in the US. Nuclear energy, too, has both opponents who focus on the danger of accidents, think Chernobyl or 3 Mile Island, as high cost, and it has proponents who cite the relatively small amount of air pollution from nuclear fuel when compared to fossil fuel and with no accidents. The views of scientists have been the focus of this paper, so it's appropriate for me to note that the Federation of American Scientists and the Union of Concerned Scientists, both prominent organizations that represent a lot of activist scientists, both have consistently opposed nuclear weapons, while their membership seems to have mixed views about the need for nuclear energy. The nuclear arms race dominated the second half of the 20th century. One of the major actors in that drama, the Soviet Union, disappeared in that period, but not the weapons. One may hope that we are now moving more purposefully toward disarmament. Thank you.
I guess this is on. Wow. Thank you very much. I'd like to now jump right into the discussion. Looks like Jeff's got some comments.
Thank you. This is very difficult material. There are many things missing from here, and part of the goal of this is to pass this knowledge on to another generation. Now, one of the aspects of it, and this is to this next generation, is what happens to the residual nuclear material even if the weapons are decommissioned. Are they really decommissioned, or are they simply put on the shelf ready to be pulled out at another time? And the second part that's missing from here for this generation is a euphemism called battlefield weapons, which we don't discuss here at all. And in discussing the last events between this agreement that's even sitting as we speak between Russia and the United States, there's no discussion, and I was trying to find this before we did this on the issue of battlefield weapons, and battlefield weapons sound like something that's going to happen somewhere out of town. By now, we already know that out of town, there is no out of town in all-out war. And so this euphemism needs to be accounted for. I think that the pressure has to be placed somewhere along the line in order to deal with such things, and especially to stop the euphemism. The battlefield weapons that we're talking about, each one is more powerful than the ones used on either Hiroshima or Nagasaki. And so they sound like things that, you know, you'd use at the Battle of Waterloo or something like that, and it would be out on a playing field somewhere. What we know about that is, in all-out war, is that all-out war still goes back to cities. So if there are 3,000 to 4,000 or 5,000 of these battlefield weapons still out there, they're not accounted for in this type of public relations thing. So this is like a very important aspect of awareness in the next generation. This is your stuff, next generation. Our generation has done not a whole lot about it. And so you're going to inherit it. And I think it's very important that that information be available. This type of euphemism that goes with 700 to 1,500 weapons, which already are shown within the realm of 100 nuclear weapons here, as being potentially absolutely past the threshold of acceptability. Also has to account that these weapons that they're talking about, these 100 weapons that they're talking about here, are like a very small part of that battlefield arsenal, and they are about the equal power of each other. So that there's another several thousand, many thousand of these battlefield weapons not accounted for here. Now, it may sit in an artillery shell or something small right now, but there's nothing that doesn't mean that you don't take it out and put it on the top of a missile again, or drop it from an airplane. So there's very, very much work to be done on this. And one of the aspects of approach here, firstly, we're Canadians, so we don't have the lobby power on the American government anyway. And lobbying governments doesn't seem to be kind of the thing that's there. Is there some form of organization where pressure can actually be applied at the intellectual level to bring about the kind of change that needs to be done? And the reason I say that is that we can name 40 key people, say, in the Manhattan Project who changed the world. Is it possible that there is a level of intellectual pressure that can be placed by a large number of people, a much larger number of people than that, but at a level where these things can actually be discussed and actually approached, and an awareness on the government that something needs to be done about it? If it's simply left in the realm of politics, what we can see is that very little will be done about it. And in my presentation, we'll ask the question as to what the default condition is, and whether or not war is a default condition. So if we leave this in a default condition, it's most certainly that these weapons will either be used or misused, or in another way simply be ignored. And what is the consequence of ignoring them is another thing. Even if they're no longer weapons, the consequence of the material that's there needs to be looked after. As I understand it, if you're going to deal with plutonium, you're going to have to look after it for 25,000 years. We don't have a structure to think about anything. We have no history with us that says we will look after something for 25,000 years. We don't even have very good abilities to look after our marine drilling, offshore drilling, for any length of time. So all of these things need to be raised, and I don't think that we're going to answer them here. But in dealing with the finality of the end of the age of agriculture, the reason for doing that is to bring awareness that there's a whole other area of complexity that we've entered into that we've never encountered before in our history. For example, 25,000 years of having to look after a material that we've created and make sure that it's there. And so this is a very different mode of thinking that we've entered into, and that's one of the things that the finality of this, of looking at closing an age that we could no longer afford to have, requires an entirely different kind of thinking than was ever used in that particular age. So what you see closing out from this object of nuclear winter the way that it is now, I know it's probably a cliche, but Einstein said, "I know not what weapons will be used in World War III, but in World War IV, it will be sticks and stones."
Let Larry respond to that.
Let me make some comments on Jeff's remarks. Decommissioned materials. Basically, you're taking weapons-grade plutonium, which is an element in itself, and weapons-grade uranium-235, which is 90% U-235. When it's found in nature, in uranium ore, the U-235 component is only 0.7%. So 99.3% is U-238. And what they do is have to do physically, because it's chemically the same element, physically they have to separate the two isotopes. And it's an expensive, laborious process. We read in the papers about Iran and its centrifuges today. That's what they're trying to do. For most reactors, except the Canadian, the CANDU reactors, most nuclear reactors use fuel up to 3% enrichment. That seems to work out well. If you take it up to 90% enrichment, then you have bomb material. What do you do with it when you take a bomb apart? Well, you can store the material, as both Russia and the US, and I suppose other countries do, and they have it under lock and key. We hope that the locks and keys and the security systems are good. You can also denature it. This means you can mix it with some other material. In the case of U-235, mix it with U-238. Then you'd have to go through the whole process again of separating it physically to get the fissile material back. You can also use U-235 and plutonium in breeder reactors, or in reactors in which they are bred. See, any nuclear reactor makes plutonium. For a time in this country, we thought that we were going to have a plutonium economy. We were going to take all this plutonium from the different reactors around the country and put it into other reactors as the fuel, because it's a way of maximizing the efficiency of the entire process. The dangers of a plutonium economy worldwide, however, were such that Jimmy Carter, when he was president, said, we're not going to pursue that route. It's dangerous and expensive, and we simply will bury the spent nuclear fuel rods, which we haven't learned how to do properly yet. So this country is not pursuing this reprocessing. Some other countries probably are, particularly in France. Anyway, there are a number of things you can do for security with the decommissioned materials. In 1991, Congress passed the Nunn-Lugar Act. Senators Nunn and Lugar wanted to provide the recently imploded Soviet Union with funding to dismantle its nuclear weapons safely. This was a time after the Berlin Wall fell. The Soviet Union was no longer, and they worried that a lot of former Soviet weapons technicians and scientists would go to work for Libya, North Korea, you name it, and that these weapons themselves might fall into hands of other nations or terrorists. So by the Nunn-Lugar legislation, the U.S. provides some money for the dismantlement of weapons in Russia. It's been extended to chemical weapons as well. And the fissile material is locked up under conditions for which America helps pay, also in Russia. But also they crush the missile casings. They are really destroying the weapons, so they can't be used again. They can't take them out of the garage and slap the pieces back together and use them. They would have to really rebuild the whole thing. So while it's not foolproof, while it's not a wonderful system of handling the decommissioned materials, they're doing something. As far as the battlefield weapons, also called tactical nuclear weapons, they exist. They're simply smaller than the strategic weapons, which are expected to go between continents. These go a smaller distance. They're generally smaller in explosive power. Jeffrey is entirely right that most of them are larger than Hiroshima and Nagasaki weapons. The Obama administration, for the very first time in American history, released or declassified the information about how many nuclear weapons we have. And the number is 5,113, including these tactical weapons. So that's strategic and tactical. The only number we knew before this was in about 1948-49 that the U.S. had fewer than 100 atomic bombs. And in all those decades since, the number had been guessed at, sometimes with greater accuracy than at other times, but no one really knew except people within the system. Now we're told that we have 5,113. Of these, this 5,000, it's believed that something like 2,000, if I remember correctly, are tactical weapons. They are stored, some of them are stored, a few hundred, in NATO countries in Europe. Some of these countries would like to have them removed. There doesn't seem to be much response by the Obama administration at this point for doing that. Personally, and I'm guessing here, I think Obama is sympathetic to a lot of these more striking steps for getting rid of nuclear weapons, taking the tactical weapons back from Europe and so forth. But he's limited in what he can do by a Congress that can pass legislation over his veto, putting things back in place. So not enough is happening from my perspective that I would like. As far as just a couple of other quick points, attacking cities. Some Americans take great umbrage at the thought that we would throw a nuclear weapon at a foreign city. We don't do that. We don't do such things. We're the good guys. We wear the white hats. Except they don't remember that the U.S. is the only nation in history to have used nuclear weapons in anger, and they were used against cities. And it was policy at one point until we got the ability to target weapons with such great accuracy that we can avoid cities if we wish. However, if the other side fires first, we're not going to fire our weapons at empty silos. So we're going to pick some other targets than the ICBM silos that we had initially targeted. And cities have industry nearby and command, communication, control, and intelligence facilities nearby. So even if you're not aiming at a city per se, cities will be targeted because of the so-called military and industrial targets therein or nearby. So that's why the nuclear winter scientists said, of course you have to look at cities. Cities will burn. And as far as pressure on the intellectual level, I'm not sure intellectuals have that much influence and power, but you do have the organizations I talked about, the Federation of American Scientists, the Union of Concerned Scientists. You have the Pugwash Conference movement, which won the Nobel Prize in something like 1995 for its efforts at arms control. There are groups and there are individuals out there striving for to move in this direction. And I think that the internet is incredibly helpful. I get more more emails from different political organizations that I really don't want to receive, but I'm interested in what they say. And they all want funds, which is the downside. The upside is that they tell you what they're trying to do, who the good candidates are, what the good issues are, good from my perspective. And it is such a powerful instrument for mobilizing people and money quickly and making an influence in a campaign, such as we had some recent primaries where this occurred. So, Move On, what's the Credo, I'm forgetting names, but there are a bunch of internet organizations. But I don't have the magic bullet to tell you that this is the group to pursue.
I wondered about something like the Committee of 100 from the 60s, led by Bertrand Russell, where it crossed over all kinds of disciplines, and then it was directly to the grassroots. I mean, it was an activist program because even things that win Nobel Prizes really don't touch an awful lot of people. They don't even know about it. I was thinking back to what you said, Luba, about the cultural bearers, and the scientists are the cultural bearers as well as the artists. And I would like to see that crossover.
The Einstein-Russell Manifesto of, I think it was 1955, Bertrand Russell and Albert Einstein. Einstein died within a year, and Russell, I don't think lasted much longer. But it was a public statement and an opportunity for signatories to say that we don't like the direction we're going in. We think that nuclear weapons have to be abolished, and let's do something about it. It led, within 2 years, to the Pugwash movement. Cyrus Eaton, a Chicago industrialist, was approached by, or maybe he approached some scientists, and he agreed, or he offered to host the first meeting of 2, 3, 4 dozen scientists at his estate in the place where he grew up, I think, Pugwash, Nova Scotia. So they took the name of the movement from the town, and I don't think they've had another meeting there, but they have 1 or 2 meetings a year around the world, to which scientists are invited as individuals, not as representatives of their nations. And there they're able to discuss technical issues like, what do you do about a MIRV, this space bus of many warheads atop a single missile? How do you counter that? Or what do you do about anti-ballistic missiles? These are technical people who come up often with technical solutions in addition to political solutions. There are other groups that provide technical solutions too that are funded by the Department of Defense, for example. But anyway, Pugwash has been very successful to the point of winning the Nobel Peace Prize because they were prominent scientists invited. They had rather good ideas, and their governments were interested in these ideas, and the governments liked the idea that they weren't official representatives whose hands and tongues would be tied by diplomacy. These people could speak their minds and come back with ideas that could be adopted. And this has happened over the years. So the Pugwash movement is quite alive and well.
I was wondering, like as a very young teenager growing up in Victoria, BC, I had posters from the Committee of 100 on my bedroom wall. I mean, that's how far that went in terms of the culture. And of course, the Ban the Bomb movement came out of that too.
In the late 50s, I think it was in England in 1957, CND, the Campaign for Nuclear Disarmament, was created. And in America in 1958, SANE, the National Committee for Sane Nuclear Policy, was created. Both had newspaper advertisements, marches in England, The British conceived of the peace symbol, the vertical line with the two sidelines and the circle around it, which has had many interpretations, but the artist who created it took the semaphore flag positions for N and D, nuclear disarmament, and put a circle around them, and that's the peace symbol. It got very popular. I was on the national board of SANE in America for about a decade, most of the 70s. And it's a good organization. Its strong point was public education. And I think it did that fairly well through a lot of very clever newspaper advertisements, full-page ads in the New York Times, for example. And yet, I had great misgivings about the organization. I felt that it appealed to people's heart and gut and not their heads. And I guess I like the Federation of American Scientists and the Union of Concerned Scientists because they appeal more to your head. They want to give you information and educate you.
Is there a mic that Leva can grab there? Just so we do record also the audience.
Hi, thanks so much. I'm just curious, given the fact that some of us younger folk in the room have been talking about it, and granted, several of us grew up in Canada, but I'm just curious why there wasn't more education or activism in the 80s, especially after this sort of public education about nuclear winter, or in the 90s, or currently. Like, can you kind of talk about why the trend has been to talk less about it, even though there's more countries with weapons?
Why wasn't there more activism in the 80s? The 80s came after the 70s. Profound statement. The 70s, you recall, started off with Richard Nixon and the final extrication from Vietnam. And then Jimmy Carter, who tried to cut the defense budget and wound up increasing it because Congress really overrode him. And the country's sentiment was, we don't want to cut so much. And you had in the late 70s the so-called Committee on the Present Danger, which hypothesized a scenario in which the Soviet Union would have a first strike against America's ICBM missile complex, destroying it, most of it. The U.S. submarine fleet, the ballistic missile submarines, would be intact, able to respond, but not accurate enough to fire at Soviet silos, so they would fire only at Soviet cities, a larger area target. And the Soviets would warn us, you do that, and we'll obliterate all American cities. And the Committee on the Present Danger said, no American president is going to do that. And you know, Americans don't like to be bombed or blown up or defeated in any way. We're exceptional. We have to be first and best in everything. And Carter had to respond by increasing the defense budget. So this is all background, and Ronald Reagan was part of this movement of America is a paper tiger. We have to get real defenses. We have to get real strength. And so Reagan, in addition to his missile defense ideas, which were kind of crackpot, and after billions of dollars, we didn't get very far with them. He wanted to modernize the whole arsenal, and he poured a lot of money into that. So you have all this activity of the 80s of portraying American exceptionalism and strength, and or we have to regain that strength. So there's opposition, of course, but Reagan was a great communicator. and he dominated that discussion. So there wasn't that much activity trying to deny him the opportunity to expand the weapons systems.
Oh, okay.
There is a substantial contrast, and it's one more reason why I think the history of the United States is perverse. It's simply not like other countries and should never be taken to be the rule. It's always the exception for its own powerful internal reasons. But the concept of why there wasn't mass mobilization is because ideas about war precede ideas about nuclear winter, or indeed nuclear accident. I just read this morning, 1975, evidence now incontrovertible that the Israeli government tried to sell nuclear weapons to South Africa. 1975, it's been hinted at for decades, and the documentation finally is revealed because South Africa has no interest in covering up the dirt of its old regime. And this is selling the weapons, not, nothing else implied for that particular. Now that's in the 70s, and you can see the Nixon, the Nixon hand is obviously involved in supporting Israel and South Africa in the midst of these highly difficult times. American politics just doesn't have the same sensors, the nerve endings, that Europeans do, and this is one of the dreadful, I think, assumptions we have to make, that we can't operate in the same way politically in the United States of a mass movement as you can in Europe. You can't think of the war in Iraq. The war in Iraq was supported by Americans until they realized the government lied over the weapons of mass destruction. But it was supported all over Europe. Germany, especially Germany, I think. Not only Germany, but especially so. It wasn't the case. The question I had for you is about India and Pakistan. I have some friends there, and their scientific communities and their military are sophisticated. These are complicated states. What would be your view about a direct appeal to their scientists and their military to talk this over in public? Since this is January 2010, the article is a very powerful and from what I saw, from what I read, very persuasive argument. Would you be in favor of that kind of foray? Pakistan is a chaotic state with many different centers of power. But we should not underestimate the extent to which people in these countries are aware of precisely the fact that they're at ground zero for something that could have global catastrophic meaning. Have you ever looked into this among scientists, for example, in your own specialty, Indian and Pakistanis, along with the military, to talk it through?
There are Indian and Pakistani scientists who are prominent internationally in arms control efforts. As far as them talking with or to each other, I don't know of any of this occurring. And I would think that any kind of discussion is going to be good. You should never say you're not going to talk. I fear Pakistan more than India. I think of India as a more democratic state. Pakistan, of course, is so ridden with factions, but the military controls so much of what goes on there. And you have this tradition of assassination and violence, although you have that in India as well. But mostly you have this long history of discord between India and Pakistan. And for Pakistan, which has about, 1/3 the population of India and a smaller territory, to pick fights with its larger neighbor and get its nose bloodied each time is rather strange, and yet they do it. And as far as the contested border in Kashmir, I'm not sure who's the aggressor more often than not in that region, but I don't think either side is entirely blameless. So there's so much hostility of long standing that I don't know if they can comfortably talk, or if the population at large would listen to the military and scientists who might counsel some kind of restraint. But it's madness for them to continue hostilities, particularly now that they are both nuclear powers. And then you have the whole origin of the Pakistan nuclear weapons complex with A.Q. Khan, who turned out to be an international trader in nuclear technology and materials. And I don't know how far that extends into the Pakistani military and the scientific regime and so forth. One anecdote, if I may tell it here briefly, is that I was in Kathmandu, Nepal, and when was this? Late 90s, I guess, when India and Pakistan had each exploded 5 or so nuclear bombs tests in retaliation for each other. These were tests underground, I think, for the most part. But it made headlines. One country was responding to the other. And I had just come back from a trek in the Himalayas, and I was asked to give a talk to the Nepal Academy of Sciences. And it really was on my research in history of science, but since that is about nuclear weapons at times, I got some questions about nuclear weapons. And somebody in the audience said, should Nepal start a nuclear weapons program? And he was serious. And I said, well, I really don't think so, because how many physicists do you think you have in Nepal? 20? How many of them are nuclear physicists? 1 or 2 maybe. How much money do you think this is going to cost? And so forth. Trying to indicate that this is not a way to spend scarce cash. But the very fact that they were concerned that India and Pakistan, neighbors, relatively close neighbors, whether they should get into that business too, was appalling. But this is the attitude of some people. They want to act first and think later.
For Jeffrey's perhaps comment on the 30s generation, I don't think you should eliminate the military in the 30s who are in their, as it were, formative career as professionals. There are very interesting discussions among people within the military on this issue. You shouldn't assume that they're gung-ho for using the weapons on some kind of maximization of resources no matter what. There's more going on, I think, than we realize in the world of the military, who are, after all, spending their lives with this.
Bright, thoughtful people. For example, in World War II, operations research was highly developed, and they learned the optimum size of convoys to protect them from enemy submarines. They learned the optimum size and separation of aircraft and fleets of aircraft going on bombing missions. They learned how to use science and mathematics to maximize what they were trying to do, and I thought it was very clever.
I just have a question for you. I wonder if we can go back to one sentence that I found quite interesting, where you said that preparing for war is more lucrative and less dangerous than fighting a war. I mean, to me, this doesn't take up too much of your paper in terms of the analysis, but I tend to look for the very cynical and less straightforward explanations to things. I guess, I don't know if it's a posture of my generation, but I tend to disbelieve anybody's posture, anybody's face value posture as just probably false and probably misleading. And I don't know if that's just a sickness of my generation or just my own sickness, but I'd like to hope that you could trust people at face value. And I think this posture of you is interesting because if it was something that was secret before, the idea was to confuse. So the other side really didn't know what they could expect. The US may do this, they may do that. And even if it was leaked, it was not really much of a help because the posture itself was vague. So the real policy was always not the stated policy. So that you know that the real policy makers, in the time of conflict, you could really not predict what they were going to do. Stating this now, though, out and open, you could say the same thing about it. You could say, okay, well, really in a time of conflict, they're not going to refer to a piece of paper. However, you still have to coordinate your forces. I mean, a military can't just be a last-minute affair, I would guess. I would guess they would have to have some standing orders. So in a sense, I could ratchet back slightly from my perception of complete cynicism towards the posture review and state, okay, well, at least there's some degree of certainty or a higher degree of certainty that at least the knee-jerk reaction wouldn't be in the direction of nuclear war. So like sort of a response to that. And the second would be just on this, the idea of the military-industrial complex. And where did in my paper, I was asked the question, well, where did the warrior class go, and maybe deeper than that, what about the elites? Is there not some deeper question of, do we have to somehow accommodate elite ambition? And, you know, do they just have to somehow find some arena to battle it out no matter what kind of organization we have? I mean, I know that's a really cynical way of looking at things, but I tend to like to look at it in an unvarnished way and assume the worst and say, well, you know, what if this is just, you know, we're always going to have people who kind of are really ambitious, and they're always going to kind of battle their way to the top of any organization you create. And so, you know, now they're not the landed aristocracy. Now they're the people who sit on their desks and pound it with PhDs, desk pounders, middle-aged. Are they the warrior class, or is it the Cheneys? Is it the Halliburtons? What is this fuel that's behind it? The preparation for war. Is it the 30-something-year-old officer that wants to further their career? Is there still a sort of type of feudal dynamic going on in Pakistan with the military-owned enterprises? So that's something that I would like to, you know, get to. And I think that what I'd like to also ask Dr. Winter is, I feel like despite counterintuitive, despite a sort of common sense counterintuitivity of many of these actions, and weapons buildup and ABM treaties and that things happen despite that in history. It's not like arguments to the contrary, common sense arguments to the contrary are always there. And so addressing it intellectually on the counterintuitive, this is a really counterintuitive thing to be doing, to be building massive weapons and to be rearming, in my perception, never seems to be something that helps. So that's why I moved to the opposite side to say, well, that to me deserves an interpretation. Why is it never enough to say something that's so obviously true to the common person, to the elite? What is the difference there? And so in that film, you saw there was that difference. But what happened? What is it now? I mean, that's just their own self-interest, and they just didn't give a shit about the rest of anybody else, it seemed like, except for perhaps the guy who was defending the heroes of the French Revolution. I don't know what. But anyway, so I'd like a comment from you on what is that explanation. I'd like a comment from you on what is this military-industrial complex? Is it a parallel in some way? And, you know, people who talk about peace and people who talk about love and all those things that totally failed, you know, that's great. I don't know that it really sways any of these people. It never really did before. I don't know why it would now. So forgive me for at least, you know, unvarnishing some of the love and peace in the room, but I'd like to get down to the crassness of perhaps some of the underlying structure.
I have a question that might feed into yours. I know we don't have much time left. This is probably the most obvious question possible, but I just wonder how we can balance the need to look after nuclear waste for some 25,000 years with how can we balance the responsibility to look after nuclear waste with the increasing need for energy, and what is maybe your prediction for how nuclear energy will be used for so-called peaceful purposes in the future?
And wouldn't mind. Have you been writing down those questions? Both of you, because I wouldn't mind just getting the final questions and then letting them answer. If you have any other comments or questions, then going to lunch, because I know it's getting cool. Anybody else? All right.
Floating on both sides, and it was very eye-opening, very, very intelligent people, not in the military, in India, very supportive of such a step. And we haven't really been following what's been happening with how the government's trying to handle that, and we know in Pakistan that they're not capable of handling it right now. And I don't know what the current status is in Pakistan, or how they're going to manage this.
Okay, I'm going to let Larry answer first because it's your session, and then we'll go to Winter, and then we'll stop this session.
Well, in the interests of brevity, I'll try making very brief statements. As far as the feeling in India, as you experienced, people were very supportive of their government having nuclear weapons. I think of it in the same way as back in the 60s, it must have been, after jet aircraft became commonly available for tourists to travel, every nation had to have its own national airline. So a country that couldn't afford to feed its people nonetheless would have a few jets purchased from the U.S. probably, and probably with American pilots, with their national flag painted on the airplane. It's that need for prestige. And I think of it in the same way with nuclear weapons, that a country feels that if we're going to be a significant player on the world scene, and certainly China and India are the countries to watch in the rest of this century, among a few others perhaps. China has nuclear weapons. India looks upon China as its major potential adversary. So it feels it should have it for protection, of course, never for aggression. But anyway, it's a terrible cycle, and we've seen it before so many times, and I fear we might see it again in the future. As far as nuclear waste versus the need for nuclear energy, the waste materials have some energy in them. The cost and the danger of extracting that particular energy may be so high that we don't go that route. We may just mine fresh uranium and make new fuel rods from that rather than use some of this old material in the fuel rods. So that remains to be seen. It's going to be more an economic decision, I think, than a national security decision. What is the warrior class today? Well, I think we eliminated the grunt, the chap in the foxhole, from the warrior class. It has to be the officer class. And now, I don't know, I'd probably be willing to include some CIA officials, the people who sit in these windowless rooms and control the drones that fly over Pakistan and Afghanistan. I'm not sure where I would stop. I don't know whether I would include the defense secretary or Leon Panetta, the head of the CIA, among this warrior class, but why not? It's a matter of definition. I think you asked about the military-industrial complex. It's alive and well. Recall that when Dwight Eisenhower gave his farewell address, which had to be in, early 1961 or so? Kennedy was elected in the 60s, so I guess Eisenhower gave his farewell address either at the end of 1960 or early in 61. 61. No, I'm talking about Eisenhower leaving.
February 1961. Remember, you have to inaugurate the president.
Right, but I
Okay,
don't
so it
know
was like-
how.
I think it was 3
I don't
weeks
know how
before.
far in advance of Kennedy's inauguration.
Yeah, I think it was 3 weeks.
He gave that. But anyway, we don't know how much Eisenhower really was tuned into that particular warning about the military-industrial complex, which some people call the military-industrial university complex. Malcolm Moose was his speechwriter, a man who became president of the University of Minnesota, I think, afterward. And I don't know how much Eisenhower appreciated that that would be the one line remembered in his speech. But let's say that he was cognizant of it. It was a good line, and it was a good warning. The military-industrial complex has put the U.S. on a permanent war economy, as economist Seymour Melman from Columbia called it, whereas before World War II, Navy warships were built in the Bath Navy Yard in Bath, Maine, a private company. You had a few Army arsenals that made some bombs and missiles and such, but mostly it was geared up in wartime. If you look at the industrialization in World War II, where Detroit changed from making cars into making jeeps and tanks and things like that. So American industry responded magnificently to the buildup, but after World War II, a lot of that continued. And that's why Melman called it the permanent war economy, because we had so much military hardware being produced. And then there's military software. All these think tanks, RAND Corporation leading the bunch. But RAND was a contractor for the Air Force initially, and it still does only government business, though it can do state and local business too. So the military-industrial complex is alive and well, and too well, I fear, to the point where American troops in the field are fed not by GIs peeling potatoes on KP, but by contractors hauling in everything from gasoline to the MREs and so forth. We've contracted everything out because I suppose that's the way the budget gets through Congress. You couldn't get the budget in the proper category to pay for that if you wanted to give it to the Defense Department. And finally, the knee-jerk reaction is to war, not among the military. As I said before, I think the military deserves more credit than they're given for being very reluctant to go to war, because they know that they're the ones who get hurt in war. And I think in the last 10 years or so, we've seen how war does hurt the people who engage in it, particularly the battlefield soldiers, with all the scandals at the military hospitals and the VA hospitals. It's a very unhappy experience.
Thank you. And finally, Jay Winter.
I'll be brief, very brief. I think the two issues of what might be described as popular perceptions of the dangers of accidental war and political action about it should be separated. I think you're right that the cynical can take over and destroy the popular. And I would never underestimate the extent to which there's still possibilities of getting young professionals. I don't know whether you'd agree with me now. The people I've found the most pacifist in discussions in Europe are bankers. They don't want any part of the instabilities that go along with. You can't predict anything. You can't see what an investment looks like. There are people at the age of 30 who are not blind to what you've said today and should be informed further. If you put it in political movements, I think you're likely to get co-opted or blocked or jailed or whatever else usually happens. But the bottom-up way has been available in many parts of the world. Surprisingly, human rights were clearly bottom-up for a century. And I would, an opportunity like this park is one that I think could be used precisely for that issue, is not to go the way towards the political frustrations that you talk about.
Well, I mean,
Well, why not? Absolutely.
why not?
No, but I think Jeff is right. There's an age group issue. The age of 30 is the critical age at which you can see any possibilities. Not when you're my age. It's a little late for that. But I think, your point, you started, Karen. It's a generational matter. You spoke about a generational perception. And that's where I would look for the opportunities in the future, is with the kind of work that you're doing.
Okay. Well, on that, I think we're going to end again on a great statement. Thank you very much.